Today we're going to be talking about trigonometry. Trigonometry is a Greek word that means triangle measure, which essentially is how we find the measures of triangles and according to their angles and trigonometric ratios. It's a ratio that compares two sides of a right triangle. Notice it has to be a right triangle right there at first. So here are trigonometric ratios that we need to know. Sine is the opposite over the hypotenuse from your angle A. So if I look at angle A, the opposite side would be side A over C. And if I was looking at angle B, opposite side would be B, but again the hypotenuse would be C. Then there's cosine. Cosine uses the adjacent side. So if I'm looking at angle A, the adjacent means right next to it, so that would be B over the hypotenuse C. Or if I was looking from angle B, the adjacent side would be A, hypotenuse again would be C. And finally, the last one is tangent. And tangent does not include the hypotenuse above. Instead, the tangent is the opposite over the adjacent. If that was angle A, it would be A over B. The tangent from angle B would be B over A. Notice they both use the same letters, just in a different order. Now, the way we remember this is a phrase. SOHCAHTOA. And SOHCAHTOA is sine is the opposite over hypotenuse, cosine is the adjacent over hypotenuse, and tangent is the opposite over adjacent. And I would recommend putting that in your notes somewhere. Now let's use those ratios to find some fractions and then decimals comparing the ratios in a triangle. So we're looking at angle P, and it asks us to find the sine. So remember, sine, so opposite over hypotenuse. So the opposite from angle P is 15. And the hypotenuse of the triangle, well, across from the right angle, is 17. 15 over 17. So I can write it as a fraction, or 15 over 17 as a decimal is approximately 0.88. For the next one, cosine of P. Okay, so now I'm looking at angle P again. Okay, cosine, ca, adjacent over hypotenuse. So adjacent from P would be 8. Hypotenuse again it would be 17, which would also be 0.47 as a decimal. Then finally the last thing we're looking at is tangent. So from P, tangent is TOA. TOA, which is opposite over adjacent. So that would be 15 over 8, which is 1.88 as a decimal. Okay, now for the rest of them, we can look at them from angle P then, or excuse me, angle Q. So from angle Q, if I'm looking for sine, sine is so opposite over hypotenuse. So it'd be 8 over 17. We'll check that out. We already did that. It's 0.47. So you'll see that the cosine of P and the sine of Q are the exact same. We can use that information also for the cosine of Q, which is adjacent over hypotenuse. Well, the adjacent from Q would be 15 over 17, which again is 0.88. So the cosine of Q is the same as sine of P. And then finally, tangent of Q, this one. So from Q, tangent would be opposite, 8, over adjacent, which is 15. And as a decimal, that would be 0.53. And so you'll see that because they're ratios, trigonometric ratios, they show up the same way in different triangles. Here's a guided practice problem. You can find the sine, cosine, and tangent of J and the sine, cosine, and tangent of K. Now, example 2. It says use the special right triangle to express the tangent of 30 degrees as a fraction and as a decimal to the nearest hundredth. So we're looking for the tangent of 30 degrees. So we're looking for this one. And so tangent of 30 degrees is going to be the opposite over adjacent. And you'll notice that since they both have an x in it, the x's cancel out, and so I get 1 over the square root of 3. Now, we don't like to have square roots in the bottom, so like we did in the last lesson, we multiply the top and bottom by the square root of 3, and I get the square root of 3 over 3. Okay, that is it as a fraction. Then as a decimal, that's going to be 0.577. Here's a guided practice problem. It says find the cosine of a 45-degree angle as a fraction and as a decimal to the nearest hundredth. Example 3 is a real-world problem. It says a certain part of a hiking trail slopes upward about 5 degrees of an angle. After traveling a horizontal distance of 100 feet along this part of the trail, what would be the change in the hiker's vertical position? What's the distance the hiker has traveled along the path? So I think of my trigonometric ratios to set this up. Okay, well, if I'm looking for x, I know this side right here, which is the adjacent side to 5 degrees. And I'm looking for the opposite side. Well, which trig ratio is opposite over adjacent? That would be tangent. So tangent of 5 degrees is going to be equal to x over 100. Now, if I wanted x by itself, how do I undo dividing by 100? Well, I multiply both sides by 100, and I see that x is going to be the value of 100 tangent of 5 degrees. Now you'll notice on any calculator, any scientific calculator, it's going to have the tangent button. And so all I have to do is make sure my calculator's in degree mode, which most of them will be, and I take 100 tangent of 5 degrees, and I find x to be approximately 8.75 feet. Now that I know that x is 8.75 feet, I can use that to find y. Now, if we know the opposite side and we're looking for the hypotenuse, what we would do is we would say, well, sine is opposite over hypotenuse of 5 degrees is going to be equal to 8.75 over y. And so if I was going to solve for y and multiply both sides by y, that way these cancel out, I get y sine of 5 degrees is equal to 8.75. If I want y by itself, I divide both sides by sine of 5 degrees. And I find that y is equal to 8.75 divided by the sine of 5 degrees is going to be 100.39 feet. So again, a 5-degree slope is very small, so it makes sense that 100.39 would be the longest side because it's the hypotenuse, but also would be not much bigger than 100 at the bottom. Alright, here's a couple guided practice problems. You can try the same. Now the last thing we're going to do is, what if we know sides, but we're looking for an angle? The way we do that is we use what are called inverse trig ratios. Okay? So if I know sine of A is equal to x, if I wanted to figure out what A was, I would take the inverse sine of sine of A, which leaves me with inverse sine of x is equal to the measure of angle A. We can do it for cosine, and we can do it for inverse tangent. There's also all of those buttons on your scientific calculator. You just have to hit normally the second button and then sine, cosine, or tangent. Now let's look at this in an example. It says use a calculator to find the measure of angle A to the nearest 10. Well, I know the two sides of this triangle are the opposite and the hypotenuse, because it's across from the right angle. So which trig ratio is opposite over hypotenuse? That's going to be sine. So sine of angle A is equal to 18 over 27. Well, how do I undo sine? I do the inverse sine. Now you'll see the inverse sine of sine, those two cancel each other out, and I say A is equal to sine inverse of 18 over 27, which I can just put into my calculator. And when I do that, inverse sine of 18 divided by 27 is approximately 41.8 degrees. Here's two more guided practice problems. You can try the same. Now, the last example. Why we learn all of this is so that we can solve a right triangle for all of its sides and all of its angles. So, right here, I know this side is 5, this side is 9. Well, the easiest way to probably find this side right here would be to use your Pythagorean theorem. So 5 squared plus 9 squared is equal to c squared. 25 plus 81 is equal to c squared. That's going to be 106 is equal to c squared. How do I get c? Square root both sides. So the square root of 106 is going to be 10.3. So that's how long side xy is. So that's the first thing I found. Now that I know that, I can find all of my other two angles. Well, obviously angle Z is going to be 90 degrees, but angle X, okay? Well, there's a couple different ways I can do it. I could do opposite over hypotenuse, and I could do opposite over adjacent. The easiest, in my opinion, would be opposite over adjacent. So it'd be tangent of X is equal to 9 over 5. Now, if I wanted to find that missing side, I have to do the inverse tangent. Tangent inverse. Remember, tangent inverse of tangent goes away, and x is equal to the tangent inverse of 9/5. I put that into my calculator, and I'd say find out that x is equal to 60.9 degrees. Then the easiest way to find y would be to say, okay, if that's 90 and that's 60.9, I can just do 180 minus 60.9 minus 90 and find that angle y is going to be 29.1 degrees. And I could check that using my trig ratios. So if I was going to do that, I would just do tangent of y is equal to 5 over 9. So the inverse tangent of 5 divided by 9 on my calculator is 29.1 degrees. So I know that I did it correctly just using subtraction.